Hello, my name is Tanya Furman, and I'm a professor of geosciences at Penn State University. Thank you for joining me today. We're going to talk about a type of plate boundary that often makes people feel confused, the divergent or pulling apart boundary that can exist on either continental or oceanic crust. It can be hard to think about the crust being pulled apart because we worry that an empty space might exist. It kind of looks that way in this drawing. The areas in the red squares are drawn much wider than they are in reality. Remember that the Earth takes care of us. There are never holes or gaps. First, let's make sure we know that there's rock all along the boundary. This map from Seismic Explorer reminds us that we define plate boundaries by their earthquakes. We need rocks to have earthquakes, so we know there cannot be an empty gap along divergent boundaries. Let's look closely at two areas, one in the ocean and one on land. Here I've drawn the plate boundaries on the basis of the earthquakes. Instead of thinking what happens when we rip something in half, we need to think about what happens when the Earth rips apart. Earth is big, heavy, and slow, and there's always time to fill in the tiny cracks. This image shows one such crack that formed in Kenya, where the East African Rift is growing slowly. You can see from this aerial view that the crack is not deep, maybe tens of feet deep, but the road can easily be repaired. Often, the cracks are filled with magma that solidifies quickly into new rock, and that new rock is able to fracture, so we get more earthquakes. Under the ocean, this volcanism does not form big volcanoes. On land, we may get volcanoes that we can see along the middle of the boundary. Now let's talk about the water. The thing about water is that it always flows downhill. So anytime there is a low spot, like a valley or like a crack, it will fill with water. Here in Iceland, at the margin of the Mid-Atlantic Ridge, we see a rift lake because rain, snowmelt, and rivers fill the low-lying area. This lake is fresh water because that's the water available on land. The youngest ocean on our planet is the Red Sea, which formed over the past 28 million years between Arabia and Africa. This new ocean is very shallow because it is young and narrow, and the seawater is filling in the area. One day, the Red Sea could become a big ocean, but that will take a long time. The size of the ocean depends on the magma that forms the ocean basin floor, not on the appearance of salty water.